Today we will discuss about the partial fractions. For making partial fractions, we have a function in this form fx upon gx. Both are the function of x. And second thing, we remember this one, that means the power of or degree of numerator. Degree of numerator must be less than degree of denominator. So first thing, we have to remember this one when we are going to do the partial fraction. So this thing we have to remember. That means the degree of numerator must be less than degree of denominator. So for example, when we consider example 3x plus 4 upon x square plus 5. So here we see that the degree of numerator is 1 and degree of denominator is 2. So we can do the partial fractions directly for this particular function. Okay. So we start the first rule how to do the partial fractions. We use partial fraction in various places. That means in calculus also, when we are doing the partial fractions for differentiating, for nth derivative, etc. So first rule is that, so that means when function given in this form px upon x minus a, x minus b. So px upon x minus a, x minus b. So we have directly factors. So then we write down the partial fraction. So this we can consider as equivalent to a upon x minus a plus b upon x minus b. So this function px upon x minus a into x minus b can be written as, or we can say that equivalently to a upon x minus a or plus b upon x minus b. So we make two equations for calculating a and b. So obtain a and b. How to do the partial fractions? So for such type of questions, so we can take one example. So you can easily understand how to do the partial fraction. So suppose we have a one function in this form 1 upon 6x square minus 5x plus 1. So make partial fractions of this. So first thing we have to remember when we are going to do the partial fraction. So we see that the denominator given in the degree 2 function. So we make it into the linear function. That means we do the factors. So first we do the factors of denominator. So first we do the factors of denominator. So denominator given is 6x square minus 5x plus 1. When we do the factors of 6, this multiply by 1, so 6 1 is 6. So we do the factor of 6 in such a way, so we get the total is 5. So 2 3 is 6. So 2 3 is 6, so that means 5x can be written as 6x square minus 2x minus 3x plus 1. So here we take as 2x as common. So this can be written as 3x minus 1. So 2 3 is 6. So 3x minus 1, or here we take as uh, minus 1 as common. So this can be written as 3x minus 1. So we take a 3x minus 1 as common. So second is 2x minus 1. So these are the factors of 6x square minus 5x plus 1. Now we return back to the question. So now we write down this as 1 upon 3x minus 1 into 2x minus 1. So we move to the journal form. So this is our journal form. So we make the factors in this way: a upon x minus a plus b upon x minus b. So now we write down the factors of this particular function in this form. So a upon x minus a means 3x minus 1 plus b upon second function. Basically this is the factors. So now how to solve this for finding a and b, for calculating a and b? So we calculate a and b. Calculating a and b. So when we calculate a and b, so we just do one things. So that means we take the LCM here. So 1 upon 3x minus 1, 2x minus 1 is equal to, so here we take the LCM as 3x minus 1 or 2x minus 1. So the coefficient of a will be 2x minus 1 or the coefficient of b will be 3x minus 1. So we can cancel the denominator to denominator. So we have the function in this. So 1 is equal to a into 2x minus 1 plus b into 3x minus 1. So we can write down this as 1 is equal to 2x into a minus a plus 3x into b minus b. So we know one thing. So that means we write down the equating the coefficients of x and constant both side. So here first we take the coefficient of x. So coefficient of x, we see that in LHS side there is no coefficient of x because there is no term of x. So we write down coefficient of x will be 0. So 0 is equal to the coefficient of x is here is 2a and plus 3b. So this is our equation number 1. And second, we take the coefficient of constant. So coefficient of constant LHS is 1 and RHS is minus a and minus b. So this is our equation number 2. Now we solve these two equations for obtaining a and b. When we solve these two equations, so we multiply this equation by 2. So we add these two equations, so and adding, so 2a to 2a cancelled. So this here is 2 is equal to 3b minus 2b. 3b minus 2b means b. So directly we get b is equal to 2. So we get b equal to 2. So we get b equal to 2. Now we put the value of b in any of the equation. So put the value of b in 1. So we write down the putting the value of b in 1. So we see that 0 is equal to 2a plus 3 into 2. So 0 is equal to 2a plus 6. So this we can write out 2a is equal to minus 6. So a gives us minus 3. So here we get the value of a and b. Now putting these value into the partial fraction form. So we get so we write down this as the partial fraction of 1 upon 6x square minus 5x plus 1 is equal to minus 3 upon 3x minus 1 or plus 2 upon 2x minus 1. So these are our partial fractions. So this is the basic method or general method we solve. But when but we have also other methods. That means we can use the limits. So on the basis of the factors. So on the basis of factors, so we can directly solve the problem. That means when we have the first factor is 3x minus 1, so 3x minus 1 is equal to 0, so we get x equal to 1 by 3, so put x equal to 1 by 3 and calculate the value of second factor. Okay, so this is the first case. Now we can extend this case to the another form. Another form is we have suppose px upon x minus a, x minus b into x minus c. So we have three factors, okay, because we have denominator is a cubic equation. So we have three factors. So now when we calculate the partial fraction of this, so we write down this as a upon x minus a plus b upon x minus b plus c upon x minus c. So we can solve easily by using above method. So this is the extension. So you remember one thing, when we have linear factors, so we have linear factors, so we write down partial fraction in this form. Linear means having degree 1, x minus a, x minus b, x minus c. So when we have linear factors, so we write down partial fraction in this form. So we solve this for finding capital A, B, F, C. Now, solve for finding A, B, and C. Now, second, we have another form. Another form, suppose we have function in this form px upon x minus a to the whole square or x minus b. So how to do the partial fraction of such type of function fx upon gx? So we do the partial fraction of this. So we first we check the linear factor. Okay, this is having degree 1, this is having degree 2. Okay, so how to do this? So first we write down the linear factor a upon x minus b plus, for making this factor, so this can be written as x minus a and x minus a to the whole square. So make two factors. So we write down b upon x minus a or plus c upon x minus a to the whole square, because x minus a is also the factor of x minus a to the whole square. So we make three, we take three constants a, b, and c, because we have degree 3 of denominator. Okay, so simply we solve the problem as ever for finding the capital A, capital B, and capital C. So we will discuss the questions later. Now, another form we have, suppose a px upon x minus a raised to the power 3 into x minus b. So how to do this? So same process we have follow here also. The 1 upon x minus a upon x minus b plus b upon x minus a plus c upon x minus a to the whole square plus d upon x minus a raised to the power 3. So we make the factors in this form. Okay, so remember the factors. So we first we see the denominator. That means in denominator our factor is linear. So linear factor can be written in this form. Now we move to the further. That means when we have the function in this form px upon x square means ax square plus bx plus c, or second factor is dx square plus ex plus f. Both are the quadratic factors, means quadratic factor. So if both are quadratic factor, so how to do the partial fraction of these? So we can do the partial fraction of this as ax plus b. ax plus b upon first factor ax square plus bx plus c, or plus same we do for this one cx plus d upon dx square plus ex or plus f. So this is for quadratic factor. Okay, so this is for quadratic factor, you have to remember. Now we have the mixed problem. Mixed problem is one factor is linear factor ax minus a, or another factor is x square plus bx plus c, quadratic factor. So how to write the partial fraction of this? We write down partial fraction of this. For linear factor is as in the form of linear a upon x minus a, or plus for quadratic factor is in the quadratic factor. So we write down this as x square plus bx plus c. Okay, so we remember this thing. So that means first constant we have taken a, so for another constant we take as b and c. So now you have remember, that means the power of numerator should be less than power of denominator. We make the partial fraction easily. If some cases are there, so when we have a degree of numerator, that means the degree of numerator is greater than the degree of numerator is greater than degree of numerator is greater than denominator. So first we divide. So in this case, first we divide numerator by denominator, then make partial fraction, then make partial fraction. Okay, so we take one question related to above formula. So that means suppose we have the function in this form. Two x plus 1 upon x plus 2 x minus 3. So for this term we can do the partial fraction directly. So that means we write down this because the power of numerator is less than power of denominator. So we write down the first factor x plus 2 plus b upon second factor x minus 3. So we can use direct formula here. So what is the direct formula? So we directly check the factor of first term. So factor of this, so that means x minus 2. So when we are taking the factor of this term, that means x plus 2 is equal to 0. So x gives us minus 2. So we put this factor into the given function. So this is fx upon gx. Okay, fx upon gx by removing this factor x plus 2. So by removing this factor x plus 2, so we do not use this factor while putting x equal to minus 2. So we put x equal to minus 2, the 2 into minus 2 plus 1 upon minus 2 minus 3. So the, for finding a. So this gives us minus 4 plus 1. So this is minus 4 plus 1 upon minus 5. So this equal to minus 3 upon minus 5. So this gives us 3 upon 5. So this is the value of a. So 3 upon 5, the value of a. 3 upon 5 is the value of a. Same for calculating the value of b. So the factor of b, you see that. So we put x minus 3 equal to 0. So x equal to 3. So we do not use this factor x minus 3. So we eliminate or we remove this factor. We do not use this factor. Now we use this factor. So we use this factor for the second one. The second one, so then we put x equal to 3. So this gives us 2 into 3 plus 1 upon 3 plus 2. So we calculating the factor b directly. So 2 3 is 6 plus 1 7. 7 upon 5 equal to b. 7 upon 5 equal to b. So these are the values. So we have calculated directly without making the equation. Now when we verify these values, so we make the equation. So when we make the equation, so we do not write a denominator again. So we just write the numerators. So 2x plus 1 is equal to a into coefficient of a is x minus 3 or plus b into coefficient of b is x plus 2. Okay, so equating the coefficient of x and constant. So coefficient of x is 2 and coefficient of x is here is a or plus b, and coefficient of constant is 1. 1 equal to minus 3a plus 2b. So we have two equations. Now solve these two equations. So we multiply equation 1 by 2 and subtracting. So when we subtract this, so we change the sign plus and minus. So 2b to 2b cancelled, and this gives us 2 to the 4. 4 minus 1 is 3. So 3 is equal to 2a plus 3a means 5a. So a we get as 3 upon 5. So we already calculated here. So put the value of a in equation number 1. So we get 2 equal to 3 by 5 plus b. So 2 minus 3 by 5 is equal to b. So 5 to the 10, 10 minus 3 is 7 upon 5 equal to b. Okay, so hope you understand. You can use the direct method or you can solve by using the equations. Now we do the partial fraction of second form. So that means suppose question is given as 2x plus 3 upon x minus 5 to the whole square. So do the partial fraction of this. So first we see that the power of numerator is less than power of denominator. So when we do the partial fraction, so when we do the partial fraction of this, the partial fraction will in this form. So a upon x minus 5 or plus b upon x minus 5 to the whole square. Okay, so this we can write it 2x plus 3 is equal to, so the coefficient of a will be x minus 5 and the coefficient of b will be 1. So we take the coefficient of x. Coefficient of x is equal to 2, 2 equal to a, and coefficient of constant 3 equal to minus 5a or plus b. So 3 is equal to minus 5a, so minus 5 or a equal to 2, so minus 10 or plus b. So b gives us 13. So b gives us 13. So the value of this we write down as 2x plus 3 upon x minus 5 to the whole square is equal to a 2 upon x minus 5 or plus 13 upon x minus 5 to the whole square. When we verify this answer, the answer is correct or not, so we take the LCM. That means x minus 5 to the whole square, and the first term will be x minus 5 into 2 or plus 13. So this gives us 2x minus 10 plus 13 upon x minus 5 to the whole square. So 2x plus 3 upon x minus 5 to the whole square. Verified. Okay. So this is our second case. So we make the partial fraction of this. Now we move to the another case. So when we have the 3x plus 5 upon 2x plus 1 first factor, और x square minus 4 is second factor. So how to do the factor? So we can do the partial fraction of this. So first we will do the factor of this term also if possible. So we can write down this term as 3x plus 5 upon 2x plus 1 is first factor. Then we make the factor of this factor. So x square minus 4 means a square minus b square, so a plus b, a minus b. So we can write down as x minus 2 and x plus 2. So when we make the factor are in linear form, so do the partial fraction in this form. So a upon 2x plus 1 plus b upon x minus 2 or plus c upon x plus 2. Okay. If it is not possible to make the factor of quadratic term, so we do the another form. So you can solve easily for finding the value of a, b and c. Now we have suppose the question in this form: 3x plus 4 upon x plus 1 into x square minus 3, x square minus 3. So how to do the partial fraction of this? So we do the partial fraction of this in this form. The denominator is cubic, so we use 3 constants obviously. So first factor we write on a upon x plus 1 or plus second factor will be bx plus c upon quadratic factor x square minus 3, x square minus 3. So write down directly 3x plus 4 equal to, what is the coefficient of a? The coefficient of a will be x square minus 3, and the coefficient of bx plus c will be x plus 1, x plus 1. So we simplify this. So we write down ax square minus 3a plus bx plus c. So this can be written as bx square plus cx plus bx or plus c. So we write down this as a plus b into x square, and b plus c into x or constants minus 3a plus c. Okay, so this equal to 3x plus 4. Now same equating the coefficient of x square, x and constant. Equating the coefficients of x square, x and constants both sides. So coefficient of x square, LHS is 0, 0 equal to a plus b. So we have first equation, coefficient of x is 3, 3 is equal to b plus c. This is equation 2. Coefficient of constant, constant is 4, 4 is equal to minus 3a plus c. We remember the sign of constant term also, we use that. Now we solve these 3 equations for obtaining a, b and c. So from 1 and 2, so we take from 1 and 2, we put a equal to minus b. So that means, or we can say that b equal to minus a. So this 3 equal to, in place of b we put as minus a plus c, and equation third, equation 3 we write down as 4 equal to minus 3a plus c. Now solving these two equations, so on subtracting, so we cancel c to c, so this gives us minus 1 equal to plus 3a minus a means 2a. So a is equal to minus 1 upon 2. So a equal to minus 1 upon 2. When we put the value of a in equation number 1, so b gives us 1 upon 2. So from 1, b equal to 1 upon 2. B equal to 1 upon 2. Putting the value of b in equation number 2, so we see that so 3 equal to 1 by 2 plus c. So 3 minus 1 by 2 equal to c. So c equal to 5 by 2. C equal to 5 by 2. So the factors of 3x plus 4. So factors of 3x plus 4 upon x plus 1 or x square minus 3. X plus 1 x square minus 3 is equal to a minus 1 by 2 x plus 1 plus b 1 by 2 x plus c 5 by 2 upon x square minus 3. So you can write down this as minus 1 by 2 x plus 1 or plus 1 by 2 taken in the denominator, so it can be written x minus 3. So hope you understand the partial fraction.